Hello everyone, this is John, and today I want to share with you a statistics tutorial on how to do interpolation. If you are in an introductory statistics course or taking statistics either at the university or college level, you will probably, if not already, encounter interpolation. Interpolation is one of the first concepts that is taught in an introductory statistics course, and is usually found at the beginning of most statistic book chapters, particularly chapters that focus on frequency distributions. The reason I'm putting together this tutorial is specifically because interpolation seems to be a pretty hard concept for most undergraduate and college students to grasp. And from my experience working with students, marking statistics exams and midterms, that very few students seem to grasp the concept of interpolation. So before I go into any detail, I just want to quickly lay out how this tutorial is set up. I'll first explain what is interpolation and then mention some main caveats that university and college students need to consider when doing interpolation, which is particularly these real limits here, and I'll explain what that is. And then from there, I'll go into some example questions with solutions. I'll go from a question where we ask about the percentile to a raw score, and then from a raw score to a percentile. If you feel pretty comfortable with interpolation and don't really need a review, the next few videos I will make on this subject will be questions with solutions. So feel free to tune in for those. So, what is interpolation? Interpolation is a method for determining percentiles and percentile ranks in a frequency distribution table. And that is exactly what I am presenting here. I've created a frequency distribution table, and interpolation uses these tables to create estimates from the table that aren't clearly set in the table. If at any reason you are not familiar with what exactly is a frequency distribution table, I would highly recommend looking that up beforehand before even attempting interpolation, as you need to have a bit of a basis of what this table is representing. Just quickly, I can mention that the X here represents the raw scores, the F represents the frequencies, so how many numbers were accounted for each raw score. The CF is the cumulative frequency, meaning pretty much the amount of people in the entire table. And then the cumulative percent, it goes from lowest to highest with 100% of the entire sample being accounted for. But the idea here is that with interpolation, we can use it to calculate any values that we do not directly can see within this table. So for example, a pretty standard interpolation question would be, what is the raw score at the 45th percentile? And you can see here, when looking at the table, looking under the cumulative percentages, we actually don't have a 45th percentile. It must be somewhere obviously between 50% and 40%. But because we do not have that percentile here, we cannot go across the table to see what the raw value score for that percentile is. But with interpolation, and which I'll show momentarily, we can figure that out very quickly. But before I go into the interpolation question, this is the caveat that I mentioned at the beginning that I wanted to cover. When it comes to raw scores in a frequency distribution table, they have what is called real limits. And those real limits are on the upper side and lower side. And all this really means is that these scores on this under the X, for example, are not single data points. They're actually intervals. And what that means exactly is that if we have a raw score of 4 here, this value does not just represent 4, but it represents anything from 4.5 to 3.5. Hence, it's actually an interval. So for example, if a question asks what is the raw score at the 50th percentile, the idea here is you don't need interpolation to answer this question, because the 50th percentile is actually within the table. But the trick here, and the caveat which I'm trying to emphasize, is that if we see the 50th percentile, we can go across the table to the raw score and see that it is a value of 3. But remembering that this value of 3 is not a single data point and represents a range of values from 3.5 to 2.5. So the answer in this situation isn't 3, but the answer is actually 3.5. So a raw score at the 50th percentile is actually 3.5. All right, so with that stuff now covered, let's try an interpolation question. So this question asks, which was previously asked, what is the raw score at the 45th percentile? As I was mentioning, the 45th percentile is not obvious here. It's not clearly written in the table, so we'll use interpolation to calculate this. So the first step is to find the width of the cumulative percentage interval. So on this side, we need to find the width between 50 and 40. And that's very simple. You just subtract the two values to get a value of 10. The next step now is to find the difference between that upper limit and the 45th percentile. Here the upper limit is 50, and 45th percentile is the value that we're looking to uncover. So 50 minus 45 equals 5. And with these two values now, we can create our fraction. The width of the interval was 10, and the difference between the upper limit and our value of 45 is 5. So we get a fraction now of 5 over 10. The next step now is to switch gears and move to the other side of the table. We figured out the fraction for this side of the table, but now we need to move to this side of the table to find the width of this interval. And as I was previously mentioning, when it comes to raw scores in a frequency distribution table, they have real limits. So in this situation, instead of minusing 3 from 2, we're actually going to minus 3.5 from 2.5 to get a value of 1. Now that we have this value of 1, we can actually combine that with our fraction, combine them together, or really multiply to get the next value for the next step, which is 0.5. And with the final step now, once we have this value, the difference between the two intervals, we just subtract this value from the upper limit on the raw table side to get a value of 3. So for this interpolation question, a raw score at the 45th percentile is actually a value of 3. At first, this might seem like a trick question because 3 is already being presented within the table. But this is where I'm going to emphasize that caveat once again. If I ask someone, what is the raw score at the 50th percentile? It is technically not 3 because 3 represents an interval. The real answer in this situation is 3.5. So to go back to our answer from the interpolation question, an answer of 3 would make sense that it isn't with 50%, but it's actually with a value lower than 50%, which is 45. Now the next question, another interpolation question. We started at this side of the table. Now let's move to this side of the table and do another question. All right, so the next interpolation question asks, what is the percentile when x equals 4? So this is another pretty standard interpolation question. 4 is not clear within the table, so we're going to have to use interpolation to find the width of this interval and then to move to the other side to find the width of this interval. So following the exact same steps as the previous question, just on the other side this time, we're going to find the width of this interval first. But because we're working with the raw scores once again, this is when those real limits come into play. So for example, instead of minusing 5 by 3, we're actually going to subtract 5.5 minus 3.5 to get a value of 2. Now that we have the width of the interval, the next step is to find the difference between 5.5 and 4. Once again, the real limits still apply here because we're still working with the raw scores. So 5.5 is the upper limit and 4 is the value that is given in the question. So when we subtract 5.5 from 4, we get a value of 1.5. So now we actually have our fraction. The width of the interval is 2. And then the difference from that upper limit to the value of 4 is 1.5. Now we switch gears and now move to the other side of the table. Here we have 75 and 40. We have to find the width of this interval now so we can calculate the difference. All we do is minus or subtract 75 by 40 to get a value of 35. And now the next step is just to combine those two values, those two interval values, to find the difference between them. So we take our fraction of 1.5 from this side and then multiply it by 35 on this side to get a value of 26.25. And now the last step, once we have this value, we can subtract that from the upper limit on the percentile side. So all we do now is take 75, subtract that value we calculated to now get our answer of 48.75. And here is the answer. A percentile when x equals 4 is actually 48.75. So in summary, interpolation allows you to calculate any values that do not directly appear in the frequency distribution table you are looking at. Always when you're working with those raw scores though, keep in mind those real limits, the upper and lower. If you're working with a whole number such as 3, 4, or 5, you know it's going to have upper and lower limits. So if you're working with a value of 3, it's probably going to have a 0.5 upper limit and a 0.5 lower limit. But if at any time while you're doing these calculations and while you're attempting interpolation, always double check your work. And one of the easiest things to do is to just do the question in reverse order. Once you get your answer, go through the question again, but in reverse to see if it matches the original question itself. And here is an example. So in the first question, when it was asked for a raw score at the 45th percentile, we received an answer of 3. Now with that answer of 3, we can recalculate this side to see if we get a value of 45%. And here is all the steps now on how to do that. The first step, because we're working with the raw scores on this side, is to always keep in mind of those real limits. Here we have an answer of 3, but the idea is we can use 3.5 minus 2.5 to get 1. Subtract 3.5 from 3, that upper limit, to get 0.5, and now we have our fraction. Once we have the fraction for this side of the table, now we switch to this side of the table. 50 minus 40 equals 10. Now that we have this value, we multiply the difference between the two intervals, which gives us a value of 5. With that value of 5, we subtract it from the upper limit here to get the value of 45. And that is the answer. You can see here that we've matched the original question, that it was at the 45th percentile. So if you're not really sure if you got the correct answer originally, you can do this in reverse order to make sure it's matching the original question. Thank you so much for watching this presentation.